please introduce yourself and say a couple of words about yourself, because you did the work that basically the rest of us are using. So it will be fair that, you know, we actually know who did this great work for the open source community. Okay, thanks.
Okay, thank you. Okay. Hey, and hello, my name is Hyungjoo Park, and I'm currently working as an internship in Professor Jedok's lab in Hanyang University, Korea. And so today I'm going to introduce how to generate layout in Magic with LAYGO2, and I think you already used it once. Okay, can I start it now?
Yes, yes, please do.
Okay, so today I'm going to track of the documents which introduce how to set workspace and generate and running LBS test with NetGen. Okay, so first we need to set workspace to connect to Magic and LAYGO. So go to the workspace directory and clone the workspace repo from the GitHub. Okay, and go to the and you need the sub module, which is on LAYGO2. And update it. Okay, then initialize the magic template cell search path by typing the following commands. Okay, then start magic with the script, because the script initialize the startup script of magic, such as dot magic in it. Okay, and check path. Let's check path, and you can see logic generated and micro template and library is included in the search path. Okay, then go to the magic layout further. Check if the directory is already created. Oh no, logic generate directory is not created, so just generate. Okay, so we are going to generate example layout files in this directory. We go back to the workspace directory, and now let's test the setting Python and LAYGO2. Before we set, I just note that LAYGO2 needs some prerequisite packages such as a NumPy, and to set some Python paths, we need IPython or PyCharm. And in this tutorial, I will use IPython. So first, set environment paths with specialty in this directory, and create IPython profile. Okay, so IPython profile is just generated, and it prints where this config file is generated. So we have to copy and overwrite the initial setting into this IPython config file, which is already generated here, IPython config by init. We are going to overwrite the script into here. So, overwrite it. Right, and let's check system and print. Okay, as you can see, the LAYGO2 is included in the Python search path. So now we're finished the setting Python for vanilla LAYGO2. Okay, let me see. Okay, then next is generate the example the flip-flop layout, which is a good example for basic hierarchy of cell. But as the flip-flop is composed of inverter and tri-state inverter and so on, so we need to generate subcells before generating the target D flip-flop. So we're going to generate tickle files with the command here. Generate inverter and generate tri-state inverter. Finally, tri-state inverter with one finger here. Okay, now we generate tickle files. Let's have. Okay, if LAYGO works well, then the example tickle files are going to generate it in the workspace directory. And we're going to generate layout file by running these tickle files on Magic. So start open Magic and run these files with first command. Right here in the turn, two fingers, and with four fingers, and tri-state inverter with four fingers. Finally, tri-state inverter with small fingers. Okay, so we just generated subcells for the effect. Now we can generate the flip-flop and close Magic, and you can ignore this warning because the actual layout files are already saved. Open IPython again, and this time run df. Okay, it create tickle files for two finger and four finger D flip-flop. And open Magic, and the same also stores flip-flop two fingers or four fingers. Okay, now we finish generating the layout. Let's check whether it's generated well. You can select the whole cell by putting a mouse point on the empty space and press F. And zoom, you can zoom fit with Ctrl Z. As you can see, the subcells are placed, and it is connected with routing methods here. That's how the LAYGO generated the hierarchy of cells. Let's see inside the subcell. You can see the inverters and tri-state inverters are generated and placed well on the D flip-flop. Okay, now so now we finished the generating layout, so we can run LBS test with the spice file extracted from Magic and the other one extracted from the XSCHEM, which is an open source schematic editor. Okay, let's extract spice from Magic first. For unclear reason, Magic often extracts only a part of netlist from the hierarchical cells, such as the flip-flop. So we have to flat this the flip-flop cell before we extract the matrix, which means we have to remove the hierarchy from this layout. So load which generated the flip-flop to finger and select top cell and pen. Then button this cell into the name CFF under a flag. And you have to load the flattened cell even after you just flatten. Okay, you can see the colors are slightly changed, and that's how the magic denotes that this layout is not a hierarchical cell. Okay, so now we can extract it. Extract. And extract spice and setting this as an LBS mode. And extract spice file. Okay, it says extraction is finished. Let's check. First, ignore this warning. Okay, you can see that the FF spice attribute file is generated in here. In principle, we should use this spice file for LBS test, but there's one problem. Since DFF is designed for used as an subcells of other cells, so it has an internal cell inside. Because LAYGO usually generated tab as a separate instance. So we have to manually insert tab before extracting spice like this. And if you can do this if you're familiar with the magic. But if you're not, in this tutorial, I prepare the matrix extracted from this insert tabs are inserted version, which is just stored in LBS. And this spice file is extracted from the FF tab, which means there is a manually inserted tab. Okay, so now we prepare the list from Magic, and now we are going to get spice from Xscheme. But I heard that there are many references, articles, and YouTube videos that introduce how to draw and extract a matrix from Xscheme. So in this tutorial, I'll just skip the drawing and extracting process. Instead, I will use this pre-extracted spice file from Xscheme. Let's see that. This is an matrix file extracted from Xscheme. You can see there is a little bit slightly different from the matrix from Magic. I will show you. Okay. You can see there the form is slightly different. We have to deal with this difference a little while after. Okay. Please see the docs here. You can see the highlighted version at in the spice script. I highlighted the parameters defined with the string equations. These parameters make a segmentation first on Magic and on NetGen, because NetGen can't read such equations composed of a string. So we have to drop these parameters before we put it into the NetGen. And this is the result version. The only parameters with the constants are remain after the process. Fortunately, the constant parameters are like the key parameters are all defined with constants. So they were dropping these parameters to not harm the LBS test process. Okay, and the LBS scheme, LBS5 is the refined version of the spice from X scheme. You can see the parameters with constants remain only. We're going to use this. Okay, so now we can finally run the LBS test. Let's go to the workspace directory and run netgen. And put this LBS command here. And if the result is similar with the following this figure, the figure in the docs, then is already set. Okay, so exit netgen, and let's check the test LBS output file, which is an output log file of netgen.
So did it pass? It looks like it says that they don't match. It says circuit 2 parallel, yeah.
Yeah. Very good question. Actually, I was about to explain what happens there. That's a very good question. Okay, as you can see, it says circuit matches uniquely, but in the same time, it also said property errors are found. What happens here? Okay, let me tell you. The first sentence tells that the topology of the two netlists are equivalent, but the other one said, okay, the topology itself is equivalent, but there's some property errors I found. So we have to check what happened, what errors are found here. And most time it occurs from that NetGen's NetGen is a not well composed program. What I mean is the parameter mismatch come from usually the parameter naming difference, not a real difference, but the difference of denoting, such as magic denotes channel length as a small L, but the X scheme uses large L, and NetGen cannot catch that they are actually equivalent. And also, X scheme uses M and NF1, and the real finger number is multiplication of this NF and M. So in this case, the finger number is 2. On the other hand, magic denotes each parameters of single fingered MOSFET. So in this case, it prints parameters twice. That means it is 2 fingered MOSFET in parallel. And as you can see, the small equals small L and large L numbers are same. W also. So we can figure out that these two networks are perfectly matched, even though that there are some property errors. So that's a drawback of NetGen. Actually, it cannot catch perfectly. You have to manipulate or just read by your own eyes and get this problem of NetGen, not netlist itself. the other networks are too. Every networks are actually equivalent, but the only problem is some other problem of notation. So actually these two net lists are equivalent. Okay, so from now it is how to run LBS tests with NetGen. One more thing I want to tell you is this command. Please take a look into this closely. Then you can find that the first one denotes the name of circuit twice, while the other one doesn't. That's because the notation difference between magic and X scheme. As I show you before. This is a byte from magic, and it denotes the DFA flat as a sub-circuit, even though there is only one circuit here. So since NetGen doesn't know which subcircuit is the top level of the hierarchy tree. So you have to tell NetGen which one is the top level of the hierarchy cell. That's why we have to denote the name of subcircuit once more for the case of magic. On the other hand, magic size from X scheme doesn't denote everything, every subcircuit, but it I think you can see there's no subcircuit terms in here because it is a real top level circuit of hierarchy. In this case, you don't need to tell NetGen which one is the top level. Okay, so and okay, and this is the last chapter of my presentation. So far, we have created layouts using the example libraries named logic generated and run the LBS test with NetGen. Now we're going to see how to create new libraries. There are two types of libraries, the personal libraries and common libraries. And the generating personal library is quite simple. Just making a directory under the magic layout with the same name of the library name, and just include the path into the dot magic init underbar personal script. Just add path to the new directory that you want to use as a library folder, like the figure at the top. And the common library is not that different, but the only difference is you can generate the library folder outside of this workspace folder. You can see the logic train, and this is I'm going to use this library for a common use library. So I'm going to include this directory path not into the magic init personal, but magic init. This this magic init. Since this file can be shared through the GitHub, but this file is not attracted by Git. So if you want to use magic logic train as a common library, then you have to include the path, directory path into dot magic in a script. Okay. Pass here, and let's test by editing the example Python code. And the Python code for an arbitrary Python code. This time I'll use Tn. I will use tiny inverter with single fingered MOSAIC. Okay, to change generation path, you have to change some variables in Python code. First, change the library name into new library name. Okay. This one, lib name code, currently is logic generate. I'll change this into the logic train. And one more parameter left. Since Magic itself cannot manage the library itself. It just have a list of the library paths. So you have to tell LAYGO that where is the logic train folder is placed. So in here, for now, this is just a current folder. So we have to change this one into flash work. Change this one into the now we finished to change the library path. Save and generate at the same process as we did previously. Magic. You can see this time the not logic generated, but logic train tiny inverter small is generated here. Open magic. Time source the run the logic train tri-state inverter. Okay. The layout is generated and equals magic. And let's check whether the layout file is really generated in the external library folder. Okay, the layout file is successfully saved at the external libraries. One more test. Go back to the workspace and open Magic again. This time not source, but just load the logic train. An inverter, press the inverter small. As you can see, since Magic can load the target cell only with its cell name. This means now we can use the logic train library with LAYGO2. That's how we create an additional libraries for personals or commonly used files. But there's one problem left. Since you cannot edit and push through the original workspace repository to GitHub. So I recommend you to fork the original workspace repository. And when the project master forks the repo, then team members can clone the forked repo instead of the default repo that I just cloned. Then you can edit the magic init and even the micro template dance library and simply push and pull. You can share it to your teammate. That is my suggestion to form a team project with this workspace repository. Okay, so far it's been a presentation of LAYGO2 and Skywater linking workspace setup and running the example layouts and LBS test. So do you have any questions? Okay, if you have any questions after this presentation, please contact me on the email I'm going to post after this presentation. Thank you for listening.
Okay, great. Thanks. Thanks a lot, Hyungjoo. I have one question for you, but it is more like operational. Would it be possible that people also, because we're trying to get this a bit more wider channel to get working, would it be possible that because if people send you a question about the enablement to your personal email, that it is like one-to-one, but if it is posted within this, let's say, channel that we're trying to bring to life at Stack Exchange, then more people will have, let's say, access to the information. What do you think? And you don't have to answer a couple of times. Answering once is gonna be enough.
So you want to open on channel or thread?
Yeah, we already opened the channels. However, and I put it in the chat. So if you can answer that way, or if emails you prefer, it's totally fine. What is important that the right information is shared.
Could I answer this question after I asked this about to Professor Jedo?
Okay. Yeah. Okay, please check with him, and yeah, let's try also this way. Let me stop the recording for now.
Guy 19, when it appears, should use the same names to be interoperative. I don't know how to say it.
Okay, so there's setting of PDK. There's a question for setting PDK, and actually we had another presentation about setting and multiple numbers of PDK with LAYGO2. So I think you'd be better to question this about after listen to that presentation tomorrow.
Tomorrow. Perfect.
Yeah, we have another presentation about what you asked.
Yeah.
And I had another question that if I understood correctly, the routing is done with the grid abstraction. There are any plans to automate the routing inside LAYGO2?
Sorry, pardon. I couldn't hear you. Sorry.
So with LAYGO2,
Achilles, I believe that Hyungjoo is more like on the let's say software developer side, and maybe Taiho and other, like, let's say Nifty Lab members can answer your question tomorrow.
Yeah, perfect.
Okay, so maybe we wait until tomorrow with a bit more details, because this was just demonstration of how you can start working. but not exactly about specifics of LAYGO2. So Taiho, can you please just he's reading the email. Yes, can you please just inform the audience for tomorrow what should we expect? You know, we talked about it today, so just to give them a heads up, you know, what are you going to present, and maybe we'll share the presentation that you already have with them. Is that what we agreed? Yeah, such that people can
Okay.
actually check it out. Can you please say a couple words?
Okay. So
I'm asking Taiho. Sorry, sorry,
uh,
Hyungjoo. Yeah.
Do you hear me?
Yes. Yes. Please.
Okay, Hyungjoo is more about like Magic and Lego, and we were gonna present about Lego. We were gonna present more focused on LAYGO2 tomorrow. So please wait for a while, and I will send Viviana next presentation PPT file for next day. And if you read those material and then please make many questions about tomorrow's presentation, and if the lab guys will answer about your curiosity. Yeah, thank you.
Thanks, Taiho. Great. Hyungjoo, I have a question for you. So because, you know, it's great that we have this video, but would it be possible that we also share the presentation that you prepared and shared with us regarding enablement of, you know, Lego, Magic with, you know, LAYGO2 with open source tools?
so you mean my presentation docs? You want me to share the presentation docs? Actually, I'm planning to edit these presentation docs and post it into the online through Read the Docs.
Okay, great. Great. So that people can actually have the source from which they can, you know, continue like learning and checking the progress. Okay, so just let us know when you do that, so that such that, you know, we all know that the material is ready to pick it up. Okay. Any additional questions regarding this specific part of the information that Hyungjoo shared with us and prepared for us? If not, I think we are at least for today